This is a quick video to explain problems numbers 89, 91, 93, and 95 in Chapter 8, Section 3. So to find the fourth roots of -1, remember we're saying the fourth root of -1 in that problem. In problem number 91, if you were to solve for z, you would subtract 1 and then take the fourth root. So these are basically asking the same question. So 89 and 91 are the same thing. In problem 93, you would add both of these terms to the right-hand side. You'd be left with z cubed. Taking the cube root of both sides, we're asking for the cube root of this complex number. And for 95, you'd subtract 1, and you'd have -1 minus I, and that would equal z cubed, so you'd take the cube root. So for each one of these, step number 1 is to rewrite this number in its trigonometric form. So -1 is the same thing as an r of 1 and a theta of pi, so we have its trigonometric form here. And the same thing with problem number 91, since they're, like I said before, they're the same problem. In problem number 93, we realized that this would be the root 3 over 2, 1/2, which would give us pi over 6, and you could do the a squared plus b squared, take the square root, and you find that your r is 8. And lastly, we have this problem here, where I did my -1 squared plus -1 squared, and we find that our r is the square root of 2. And this would be in quadrant 3. We take the arctangent of -1 over -1, which is the arctangent of 1, but in quadrant 3, that would give us the angle of 5 pi over 4. So we have the problem number 95 written in its trigonometric form, asking for the cube root by putting the 1/3 power. So to do problem number 89, since we have it in trigonometric form, we use de Moivre's, knowing that we have 4 roots. So there will be 4 of them, and they will each be 2 pi over 4, otherwise known as pi over 2 apart. So we find the first root by using de Moivre. To find the second root, we just add that 2 pi over 4, which is pi over 2, and we add that to the angle. To find the third root, we add another pi over 2, and to get the fourth root, we add another pi over 2. For each one of these, we should find, if we can, the a plus bi format, and so we would just do 1 times cosine of pi over 4, and that would give us root 2 over 2, and 1 times sine of pi over 4, again root 2 over 2. And so we have our rectangular format for our complex numbers, and those are the 8 answers to it: the trigonometric form and the rectangular form. For problem number 93, it's the cube roots. We know there will be 3 of them. Each of them will be 2 pi over 3 apart, so we find the first one using de Moivre's. We add 2 pi over 3 to each one of the roots to find the next one, but please note that 2 pi over 3 is the same thing as 12 pi over 18, so when we add those, we're adding to 12 pi over 18, and we find our 3 roots. Since this is not a known angle, pi over 18, 13 pi over 18, or 25 pi over 18, we would just leave it in its trigonometric form. We don't need to find a decimal approximation for it, and so those are our 3 roots in trigonometric form. For number 95, we're going to do the same thing as we did the previous problem. We're going to use de Moivre's to find the first root, and we had the square root of 2, which is 2 to the 1/2, raised to the 1/3. So you could just leave this in 2 to the 1/6 power, or if you wrote this as the 6th root of 2, that would be all right as well. And then we have our angle is 5 pi over 12. We're going to be adding 2 pi over 3 each time, which is the same thing as 8 pi over 12. And we end up with our 3 roots, and those are the 3 trigonometric forms of our roots.